这是你的还是我的？我在我家里面。
你的。为什么这样问呢？
知道是什么。Today I would like to make a brief introduction for multi-band impedance matching using an evolutionary algorithm for electrical and computer engineering 539 project presentation. And impedance transformer is used to connect two different wires with different impedance. Usually an ordinary impedance transformer could only work at a single frequency and its odd harmonic. As it is shown in the right, and a return loss is used to evaluate the power transmission. When the return loss equals to 0 dB, it means that there is zero power transmission and 100% power reflection. When the return loss is around minus 30 dB, the power transmission could reach 99%. The goal of this project is to design an impedance transformer which could work at 3 different individual frequencies for GSM and Wi-Fi network. And a multi-band impedance transformer is needed. It is composed of 3 different impedance transformers in serial. And there are 6 variables for 3-band impedance transformer, which is 3 different impedances and 3 different electrical lengths. And we are going to use particle swarm optimization to find the optimum solution based on the evaluation of return loss at these 3 different frequencies. And we are going to coding these 6 variables into a particle, which is stands used on the green dots in this plot. And each green dot stands for a solution, and the shape of this 3-dimensional map stands for the fitness evaluation. The blue dot is generated by the green dots, which is the highest point this green dot had ever reached. And during each iteration, the blue dot will generate a blue dot. So the yellow dot is the best blue dot had ever found during these iterations. So the velocity of this green dots will be updated by the blue dots and the yellow dots, and finally guided this green dots into the red dots, which is our final result, and which is namely the global optimum solution. After 2,000 times iteration, we can find the optimal solution for our proposed 3-band impedance transformer working at 900 1.8 GHz and 2.4 GHz for GSM and Wi-Fi network. We can find that the return loss could reach minus 50 dB, which means that there is almost 100% power transmission at 3 different individual frequencies. So, which proves that this algorithm is really successful. And to evaluate the capacitance of this algorithm, we are going to use an restrictions function. It's a function with multiple local minimum and only one global minimum. So we are going to demonstrate this MATLAB program to see how these particles find the global minimum is at the 0 point. So let's run this program. You can find that these blue dots are getting closer and closer to the global minimum, and after around 30 times iteration, it already found its results. So we can stop the program and reduce the iteration time into 50, and we run it again. We can find that almost within 15 times iteration, this algorithm could find the global minimum in such a intricate function. This is really a great algorithm for 539 product. Thanks a lot for watching. Have a good night.